Okay, so thanks for this opportunity to present to you all on the REPRISE project that I've been leading for the last few years. First of all, I just want to declare the funding we received for this project, which was from an Australian Research Council Discovery Early Career Researcher Award. And I also want to acknowledge that I'm currently supported by a Monash University Future Leader postdoctoral fellowship. And finally, I have no competing interests in relation to this project. So I also want to acknowledge the many contributors to the REPRISE project. This is a protocol for our work that was published back in 2021, which includes all of the authors except for one, and that is Phoebe Nguyen, who has essentially taken the lead on all of these projects and has been an essential asset to our project over the last couple of years. And so it's been great working with everyone from various places across the world on this project. And as I'll get to the description of the last part of the project, you'll see that there's scope for even more involvement from people across the world in this project. So just some background and some general principles that effectively underlined the rationale for why we went ahead and did this project. First of all, we know that having a completely reported systematic review is beneficial for many reasons. It can enable decision makers to know exactly what we did and what we found, and then they can then use the findings of our review appropriately to guide their decision making. It can enable others to replicate what we've done and to determine how applicable our review is. Now, there's been a lot of talk in recent years relating to the open science movement around sharing data files for studies. And I think the same sort of principles can apply to systematic reviews as well, in that sharing an editable file, be it a CSV file or a RevMan file that contains all the data that you include in your meta-analysis, can facilitate the reuse of that data in either attempts to reanalyze the results of your meta-analysis or to have others update it and continually build upon that data set. And those who use software that requires a writing of analytic code, such as Stata or R, to conduct your meta-analyses, if you actually share that code that you use, then that can allow others to understand more about your analysis than you can potentially provide in the main text. And then finally, another concept related to evaluating the rigor of scientific research is this issue of redoing studies to see if we can determine how consistent the results are upon an attempt to reanalyze the original data that was collected, or to replicate the methods of an original study and determining how consistent those findings are. So there's some just general broad principles that I want to tackle on in this presentation. But some questions we had coming into the project were that we weren't really sure how well systematic reviews that were currently published, how well they were being reported, and what sort of things still review authors tend to have problems with reporting in their review, despite the availability of guidance becoming available from reporting guidelines for many years. We wanted to know how often review authors share data files or code files that they have produced as part of their systematic review, and what they think about actually making such data and code available for a review. We're also interested in knowing what authors of systematic reviews think about this concept of replicating a systematic review. So that is not just replicating an individual study, but do we need to go ahead and start replicating individual reviews as well and seeing how consistent their findings are with an originally published review? And then finally, we wanted to get a bit more information on how reproducible and replicable the findings of systematic reviews are. There is a bit of literature out there in different fields, some looking at the reproducibility of reviews in psychology, or some looking at the reproducibility of meta-analyses of diagnostic test accuracy data, but these are, and that's been useful information, but it tends to be focused on a particular area. And so we wanted a bit more, I guess, a general data set to evaluate this information on, or to explore this question on, I should say. And so that led us to this project, the REPRISE project, which its overall aim is to explore the transparency, reproducibility, and replicability of systematic reviews, primarily with meta-analysis of the effects of interventions. And we were mainly focusing on the effects of health, social, behavioral, and educational interventions. And so REPRISE consists of a series of 4 studies, somewhat interlinked studies, each tackling a different question. And what we've managed to complete so far is the first 3 studies, which I'll present on today, and then I'll outline near the end our plans for the final study. So I'll start by outlining study 1, which was essentially evaluating transparency and completeness of reporting of systematic reviews. And we were particularly interested in a relatively recent time period, being November 2020, which is when we were focusing on for this reviews. And we wanted to know several things: how complete the reporting of these reviews are, how often do authors share their review data files, analytic code, and other materials that they've collected as part of their systematic review. And then finally, what do they write in a data availability statement, which is often requested by journals. But at this point, when we were doing this study, we weren't really aware of how authors interpret and what they need to say in those data availability statements. And so the findings of this study 1 have been reported in 2 papers. So we had a paper published in the BMJ at the end of last year, which was essentially looking at the completeness of reporting of systematic reviews and the sharing of data files for such reviews. And we also published another paper earlier in the year, which essentially did a content analysis of data and code availability statements in systematic reviews. And so I'll just briefly outline the methods and results of those studies now. So the sample of reviews we were looking at, essentially what we did was we wanted to identify a sample of 300 systematic reviews with meta-analysis that were evaluating the effects of health, social, behavioral, and educational interventions. We wanted them to be indexed during a 4-week period, and so that was between November 2nd and December 2nd, 2020. And then we how we found them was by doing a systematic search of PubMed, Social Sciences Citation Index, Science Citation Index via Web of Science, as well as Scopus and Education Collection. And then we essentially ran a systematic search for systematic reviews, and essentially took a random sample of 300 of those reviews from those searches. We then had 2 authors independently collect data on the characteristics of these 300 reviews. So starting off looking at sort of general characteristics, such as the topic or the funding source, and then the reporting characteristics of those reviews, such as the search methods, selection methods, and meta-analysis methods that we used, and then the types of materials that were shared by those review authors. And then we decided to compare our sample of 300 reviews with a sample of reviews that we'd assembled several years prior, published in a study in 2016 in PLOS Medicine, which looked at reviews published in 2014. So we wanted to see what had changed between 2014 and 2020. And then we also examined each of these 300 reviews to see how many of them included a data availability statement, indicating whether data or code were available for the systematic review and the meta-analysis, either in a dedicated part of the article or essentially anywhere where they're referring to the results. And then we extracted each of these statements verbatim and essentially had one author code the content of that particular data availability statement and have another author have a go to check those classifications and then discuss any discrepancies we had in our coding of these data availability statements. So the characteristics of our 300 reviews, essentially they included a median of 12 included studies with an interquartile range of 8 to 21. Almost a third of the reviews were conducted by authors in China, which is something that has been evaluated and observed several times now, with China being a leading producer of systematic reviews of health research. But the second most common producers of reviews were those done by authors in the US and the United Kingdom. There was a whole range of different topics explored by these reviews. I should note, even our original plan, we had anticipated including reviews of the effects of health, social, behavioral, and educational interventions. Around 90% of our reviews did focus on a health intervention, and that really was because we didn't intentionally try to stratify by type of topic. We just searched all the databases and wanted to sort of see what were the most popular types being published. And so largely our results are focusing on reviews of health interventions, but they did focus on a range of different ICD categories with endocrine, nutrition and metabolic diseases, diseases of the digestive system, and diseases of the musculoskeletal system being the most common. And of the interventions, more than just about 2/3 were non-pharmacological in nature. Now, just some figures from this study. When we look at the reporting of reviews done in 2020 versus back in 2014, what we notice are several things. Firstly, for many of the items that we were evaluating in this study, there weren't that many, there weren't really major improvements in reporting over time. We have some characteristics such as more reviews in 2020 are more likely to cite a reporting guideline and to report a search strategy for at least one database. So gone up from 55% to 72% of reviews. But for the most part, most things are staying relatively the same. I mean, I can see that some things are already well reported in nearly 100% of reviews anyway, such as our eligibility criteria and conflicts of interest statements. So there's not really much scope for improvement over time. But other things such as reporting whether you've worked from a protocol for your review hasn't really changed much at all since 2014, going only from 35% to 42%. And even something's going down slightly, such as the methods used to assess risk of bias. So we haven't seen a great increase in completeness of reporting for several items in our sample. Now, another question we wanted to ask was, what is the impact of reporting guidelines such as PRISMA? And in this figure too, it essentially lists many items that we evaluated for their reporting completeness. And essentially we divided reviews into those that claimed that they used the PRISMA statement or another reporting guideline to guide their reporting versus those that made no mention whatsoever about a reporting guideline. And essentially what we found is across the board, there wasn't really any evidence that the reviews that say they use PRISMA were reported more completely than those that don't. And so as you can see in these bar charts, it is quite variable on what sort of things are reported, but the differences between the reviews that say they've used a reporting guideline versus those that don't are not that different across the board. So I think I often point out that having led Prisma 2020, it's very nice to see, at least I guess for my citation record, how many people are citing a guideline like Prisma. But if we're seeing a lot of people merely just saying they're using the guideline rather than actually using it and using the guidance, then that suggests that there's something more we need to do as methodologists to help people or help implement these reporting guidelines into practice. And then final thing we were looking at was how often do review authors share the underlying data sets and code files. And so I'm talking about an editable file as part of their review. And only 20 out of these 300 reviews did so. And I think about maybe 8 or 10 of those were Cochrane reviews, for which it's by default a Cochrane review. When a Cochrane review is published, the RevMan file is uploaded to the website by default. So I'm not even sure if all review authors of Cochrane reviews know that, but you can find the data file for such reviews. What we were also interested in seeing is whether people who publish in journals that have a mandatory data sharing requirement are more likely to share their systematic review data files than those published in other journals. And we found overall, yes, sharing of any material tends to be more frequent in those with a mandatory requirement, but still it's not a huge percentage of these reviews doing so. And I think it has something to do with, as will come clear in some of the later elements of this presentation, I think that there's still a bit of unfamiliarity with this concept or need for sharing of systematic review data. And so there might have been more attention by journals in evaluating the sharing of data from individual studies and less so for systematic reviews. So taking a look at the next component of that study, looking at data and code availability statements, what we found was that only 29% had a data availability statement, none had just a code availability statement, and 2% had both a code and data availability statement in their review. So this it's about 70% of systematic reviews are published in journals without any mention of the availability of the underlying data. And in terms of the 93 data availability statements that we then analyzed and evaluated what the authors were saying in those statements, we found that 13% were indicating that the data files were publicly available and provided a link to the data set that could be downloaded. 42% claimed that the data were available upon request, and that's all they said. And then around 40% essentially implied that data sharing is not really, well, sharing of editable data files is not really applicable for systematic reviews, with 23% simply just saying all data are in the article, or some 10% saying no data sets were generated or analyzed, which doesn't really make sense because all of the reviews in our sample had conducted a meta-analysis. So they had done some data analysis and collation of data to include in that meta-analysis. And around 8% said that the data are from the published literature. Therefore, I think therefore they're essentially implying that there's no need to share it, the sets that they used in their review. And so just taking a look at some of these statements, so some people say that data sharing is not applicable in this instance for their review, as the data are secondary data drawn from already published literature. Some saying the studies are available online, or others saying this paper is a review and the data are from the published literature. And so while all these statements are, well, at least part of these statements are true in that a lot of these are, we were looking at aggregate data meta-analyses for which people have obtained data from published papers, I still think there's value in actually making your data set available so that others can build upon it or scrutinize it in some way, rather than relying on them just reading off the information from a table or a forest plot. It can just speed up this process of making this information available publicly. Others said some somewhat nonsensical statements, such as no data were used to support this study. And this big one in the middle here kind of contradicts itself in that it says that the data sets were not applicable. No, data sharing is not applicable because no data sets were generated, but then goes on to say that the data sets that were generated are available from the corresponding request. From the corresponding author upon reasonable request. And so sometimes I think it's maybe not just in relation to systematic reviews, but maybe to other study designs as well. But I think sometimes people will just use boilerplate text for these data availability statements without thinking carefully through what they're actually saying. So in summary of study one, essentially what we found is that several items that have been recommended for over a decade and now for systematic reviews are still reported in less than 50% of the reviews. And this is even the case in those reviews that claim to follow a guideline such as PRISMA. We also noted back, at least in our sample in 2020, that data and code availability statements appear infrequently in review manuscripts. And that even those reviews that do have such a statement, the review authors are often incorrectly implying that data sharing is not applicable to their review. Now, one thing I should note is that in the time since this sample of reviews were published back in November 2020, we did release the PRISMA 2020 statement, which does have the final item in PRISMA 2020 does ask people to indicate where the data and encoder and other materials are available for their review. And so things might have shifted since then. But at least right prior to the release of PRISMA, they weren't that commonly observed. So our next study as part of REPRISE wanted to look into this issue in a bit more detail, and that was to, so what we did was we wanted to conduct a survey of systematic review authors and to hear their thoughts about sharing of review data and analytic code and other materials. And then to sort of segue into the later parts of the project, we also wanted to hear their thoughts and opinions about the replication of systematic reviews. So the results of this study have been published just last week, I think, or maybe the previous week in Cochrane Evidence Synthesis and Methods. And so we have two papers, one reporting our results of our survey on review authors' perspectives on data sharing, and another paper reporting our results on review authors' perspective on the replication of systematic reviews. Both of these surveys, essentially, we followed similar methods. So I'm just going to outline the methods for both studies concurrently now. So in order to obtain a sample of systematic reviewers for which we wanted to survey, what we did was we searched, ran a systematic search for systematic reviews that were indexed in PubMed during the first 3 months of 2021, And then this essentially yielded over 13,000 records retrieved, which again sort of is a testament to how often systematic reviews are being published. And then we used R packages, EasyPubMed, and PDF tools to extract email addresses from these records, and essentially extracted a bit over 13,000 emails. Sometimes some articles had more than one email. That's why there's more than the number of records. And then when we removed duplicates or ineligible emails that were ineligible for other reasons, we ended up with about 9,000 retained, who we would then be able to approach for our surveys. So the first survey on data sharing, we essentially used Qualtrics software to run an online survey, which was about 10 to 15 minutes long. excuse me, which asked authors how often they think certain materials that are assembled as part of a systematic review should be shared routinely, how often they've shared things of their own review in the past, what factors might influence their decision to share their review data, and what are some possible consequences of them sharing their data. So that was the first survey. And then the second survey, which we ran concurrently, asked people about this concept of replicating a systematic review. And so we started off by asking people what they think of different definitions of replication, given that we recognize that there are various different definitions of what constitutes a replication of a review. And then we asked people to indicate how important they think it was to do replication of reviews, and what sort of factors influence them, would influence them to either do one or have influenced them to replicate a review in the past. And so we started sending the invitations in October of 2021, and sent up to 3 reminder emails every 2 weeks, and then closed the survey in December of 2021. And so just outlining just the flow of individuals throughout this project. So we randomly divided our sample of around 9,000 emails in half, and then sent half the data sharing survey and half the replication survey. We had about 300 emails bounced from each of these samples. No idea how many ended up going to spam. What I do know is that I did get about 20 people across that period for each survey emailing me many months after the survey had closed, saying that they had found the email in their spam inbox, which I think is just a common problem with all email surveys, unfortunately. Then we noted though around 500 opened the survey and examined the consent form, with just over 400 completing each survey, completing at least one item, I should say, for each survey. So both of the surveys effectively had a 9% response rate. So not great, but somewhat, I guess, somewhat similar to many of these sort of surveys done on this topic. Now, in terms of the characteristics of our respondents for both of the samples, so 3/4 of the reviews, sorry, 3/4 of the authors had conducted at least 3 systematic reviews. We included a question in the survey asking people whether they identify as a methodologist, and 50% of them said so. I guess I'm not so surprised by that, given the low response rate to the survey and the nature of the topic. I don't think it's necessarily surprising that a large number of those people who responded and wanted to participate in a survey about data sharing or replication of reviews would, in addition to being a review author, happen also to be a methodologist. Around 50% were a PhD student or early career researcher. And then we wanted to include a question also asking for their views on the open science framework, and the open science movement, I should say, with about the vast majority saying that they completely or mostly supported this movement. Now, we had responses from individuals from 66 countries, but this tended to vary from country to country. So, for example, while I think about 15% of the emails were for authors based in China, we only had a 1% response rate for individuals from China. Whether those emails were successfully able to be sent to all institutions there, we're not too sure. But as I say, it was quite variable across the countries, the response rates that we saw. So which does limit the representativeness of our sample. Now, so starting off with the results of the data sharing survey, when we asked people, we gave them a list of things that review authors could consider sharing alongside their published article. And we wanted to know whether they thought they should be shared always, often, sometimes, rarely, or never. And just looking at what should be shared routinely, which I'm defining always or often, we found that 84% of people said that yes, they believe that we should be sharing our full line-by-line search strategy for our review. But much fewer thought we should be sharing things like the template data collection form that we used, or the data file that is used to run the analysis, with only about 56% of people saying that was necessary. And about half saying we should be sharing a list of our screening decisions for each title and abstract or full text. And even fewer thinking we should share things like a file that contains the raw data that we've extracted prior to, say, maybe doing some data conversions and then including it in meta-analysis. And then only about 43% thinking we should be sharing the code for our reviews. Some things that review authors thought that could actually help them share things more often were things like if it was seen as a normative thing to do. So if it was common in the field to actually share systematic review data files, then around 78% said that they would definitely consider doing that. Things that were not really influencing them at the moment were the things like the fact that there was sort of a recommendation from their funder or their institution to do so. So few people felt that there was that external body influencing them to share their data file. And few people felt that they'd received the necessary training to do so. Now, some things that were seen as a barrier to sharing their review data files. So almost 2/3 claimed that preparing such files is just too time consuming. It's just another thing to add onto the list of a busy academic's life in their view. Some people, around half, said that they agreed with the statement that sharing privately for those who request their data file is what they prefer to do, because that allows them to keep track of the information. So to keep track of who has access to my files, as opposed to just uploading it publicly. What we didn't find was that many people thought that it wasn't important to share, or that there was no place to share their review data. So fewer people agreed with such statements. And then coming to what some possible consequences of sharing their files were. About 50% of people agreed that if they were to make their data set available and share their files from their meta-analysis available, then others might go ahead and take that data set and publish the results before they can. Just around half also thought that people might use it for unintended purposes, and so go ahead and undertake some sort of additional subgroup analyses that might not make clinical sense. So people felt a bit wary about that. And I guess fewer people were worried, only about 1/3 were worried that errors might be found in the data set that they used, or that people might reuse. Sorry, if say someone was to take your meta-analysis data and update the review and then publish it, they were worried that some were worried that that paper might get more citations than their original paper. And that's what prevented them from sharing their data set. So those are some of the things we found about the data sharing survey. Now, when it came to the survey on this issue of replicating reviews, I think, as I mentioned, we essentially included a range of scenarios that have been proposed as possible definitions of replication of reviews. And we found there was quite varying perceptions on what was considered replication. I should note that all of these scenarios were presented to respondents in a random order, just so as to not influence the order influencing whether they agreed with the scenario or not. And so we found that almost 2/3 of people believed or claimed that they considered replication of a review to involve repeating all the steps of a systematic review, such as the search, screening, data collection, and analysis methods, using either the same methods or using some slight deviation from those methods. No, sorry, I take that back. Oh, I'm reading my slides wrong. Around 68% said that you'd have to redo all steps of the review using the same methods, whereas 61% said what could constitute replication is simply reanalyzing the data collected for an original review, again, using the same methods. So there's that distinction between either redoing every step of the review versus rerunning the analysis. But the consistent thing for this scenario was that the same methods have been applied. Only around half suggested that either repeating all the steps of a review or just reanalyzing the meta-analysis data using different methods is a reasonable definition of replication of a review. And then even fewer, so only around a third of individuals thought that repeating a review but changing the nature of the question somewhat in either tightening the question or broadening it was considered, could be considered a replication of a review. So a bit of disagreement on, and we allowed people to select multiple of these options. So some people said all of them in their listed on here, was that there was a bit of disagreement from people about whether updating a review should be considered a replication or not. Now, in terms of whether it's important to actually replicate reviews, we found that people thought it was either important or critically important. But yeah, the majority of people thought that it probably would be better to fund original systematic reviews than to fund replications of them. So I guess there is support for doing this, but not necessarily devoting a lot of resources to it from the people in the sample. And in terms of what would encourage them or what has encouraged them to consider doing a replication in the past, around half said that they thought it was easier to do than conducting an original review. And so that's why that would motivate them to replicate an existing review. But few people thought that doing so would be considered expected in their discipline. And even fewer, only around 9%, considered that replicating a review would bring them academic recognition and rewards, with several people indicating that they considered it more beneficial to their career to undertake original systematic reviews rather than to attempt replication of another team's reviews. And some things that were considered to discourage them from doing a replication or a review was so 75% considered it would be hard to publish a replication or a review. And so they didn't think there would be much value in going ahead and doing all that work, given the struggle that they might experience with publishing it. And around two-thirds thought it would be considered less prestigious than doing an original systematic review. And around half thought that this would not help them get tenure or that they'd receive fewer citations for their replication, and that this would take up too much resources. And then about a third were a bit concerned that this might create conflicts with the original review authors if, say, their findings conflicted with what was originally observed. So in summary, across both of those surveys, what we found is that routine sharing of review data and code files is really only supported by around 50% of what I would call a highly select sample of review authors that we surveyed. And we did have some very diverse perceptions on what is considered replication of a systematic review, although by and large it was considered an important thing to do, but not necessarily something that every review author would want to do themselves. And so I think making these practices somewhat normative and more rewarding and perceived to be more rewarding for systematic reviewers will hopefully increase their adoption. So as I said, there's more details in our two papers published in Cochrane Evidence Synthesis and Methods. And then, okay, the final study that I want to present some preliminary results on, which was evaluating the reproducibility of meta-analyses. What we wanted to do is we wanted to look at that sample of reviews published in 2020 and consider the extent to which the results vary when we independently reproduce the meta-analyses using the same steps and code if it was available, as was used in the original review. And so what we did with this study is we included all reviews from study 1 that used software other than RevMan. The reason we chose to exclude reviews from RevMan was that we didn't think it would be, in terms of the process of repeating a meta-analysis in RevMan is really essentially, we thought that was a bit too straightforward. You're essentially just, because it is that point and click software where we essentially assumed that there was no need to attempt a reanalysis of that in the same software because the results would not change. So instead, we looked at other reviews using the other software like R and Stata to conduct this study. We then invited all the authors of these reviews, if they hadn't already shared their data and code files publicly, we asked them if they would be willing to do that, and indicated the purposes of the study was to evaluate the reproducibility of these meta-analyses, and indicating how this study would be essentially doing it on a large number of meta-analyses, and that we will be reporting the average result across all these individual reviews rather than individually identifying the authors of these reviews. And then essentially we attempted to reanalyze the data for the first meta-analysis published in that review using either the data or code supplied by the author. If it was not supplied, we then essentially took and extracted the summary statistics that appeared on the forest plot and entered that into the software. And if that was not available, because we know that some reviews will publish a forest plot that only provides you with the effect estimate and the confidence intervals, then we extracted that information and attempted a reanalysis based on that information. And then we compared the original and reproduced results for those meta-analyses. And then so we had a sample of 119 reviews that use software other than RevMan. Of these 9, so 8%, did not have sufficient data for reanalysis, either when we contacted the authors or just on the forest plot. And this was really the case where the authors don't provide the results of each study contributing to the meta-analysis. Instead, they just provide you with the pooled result. Vast majority, so 96 or 81% of the meta-analyses were considered fully reproducible. So once we reran the analysis, we obtained exactly the same effect estimate and confidence interval. Whereas for 14 of the reviews, so 12%, we considered those meta-analyses only partially reproducible, in that we could only re-obtain the same effect estimate or the same confidence interval, but not both. And in terms of what we were effectively, the vast majority of reanalyses that we were doing was essentially done on having extracted the effect estimates from the forest plot rather than getting the data sets from the individuals. So of 119 reviews, only 22 of the authors provide some or all of the requested data, but 5 specifically declined to provide their data files. Now, while I said that there were some that were only partially reproducible, across the board, though, we found that from these meta-analyses, there were no real meaningful differences observed between the original and reproduced results in the majority of, nearly all the cases. So while there might have been some slight differences in the size of, say, a standardized mean difference or a risk ratio, the difference wasn't large enough on reanalysis to actually change the conclusion of the review, which is somewhat reassuring. But as I said, this step of study 3 was really just looking at reanalyzing the data that already appeared within a meta-analysis. Our final study, which we are about to embark on, is going a step further and seeing if we can actually repeat various additional steps of a systematic review and evaluate the extent to which the results vary. And so what we want to do is we want to crowdsource teams of individuals to rerun the searches for all the databases that were originally consulted, re-screen a set of abstracts and full text reports that were obtained, and see if we come up with the same judgments about eligibility. We want people to collect data from the studies included in one of the meta-analyses, and generate their own meta-analysis, essentially following the methods that have been articulated in the review report, and then essentially summarize their results, and also participate in an interview with us about any possible discrepancies. And each people who's contributing to these replications will be invited to co-author the results, sorry, the paper presenting the results of this study. And essentially we'll be opening up recruitment for this process in around the middle of the year. So we'll be advertising and recruiting for that this component of the study quite soon. And so essentially what we're trying to find is whether we do see major differences in the results of meta-analyses on average when other teams experience in systematic reviews and in the nature of the topic are given an attempt to redo the review. So just to wrap up, I think looking collectively across this series of studies, what I think are some key messages that I guess I've learned from this process is that I think more work is needed to help review authors report their systematic reviews completely. I think our publication of reporting guidelines is not really enough in terms of getting them into getting their proper use. And I think various incentives are required to help convey to authors the benefits of sharing their data and code collected for their review, particularly when people such as myself come along and ask for them to contribute to or participate in these evaluations of reproducibility. And I think there needs to be a bit more work on to help people consider the benefits of possibly contributing to replications of systematic reviews as well. So just a take-home message is that this REPRISE project we've been doing has been exploring how transparent and reliable reviews of interventions are, and we hope that the findings will inform strategies to improve the openness of future reviews. And so those of you who are interested in maybe contributing to the replication attempts that we'll be doing in the latter half of this year, you can contact me by email or Twitter, and yeah, we can go from there. So I'll just stop there now, Joanna.